Hi you lot. Okay, so today's lesson, so it's Friday, last lesson. What we're going to do today is revise some GCSE concepts that you really need to understand fully, linked to the hydrological cycle, so that when we talk about new stuff next week, you understand these concepts. So the concepts that you need to understand by the end of the lesson are the global atmospheric circulation, factors that affect temperature, and different types of rainfall. So some of you might remember this really clearly from GCSE, and others it might seem so long ago that you've forgotten all of it. So what I'm going to do is go through each of these concepts, try and explain it. You can make notes, you can pause, you can fill in the sheets, or you can listen to the whole video and then complete the tasks. Totally up to you. Okay, so first task is to just match up these sentences. So I'm just going to go through and tell you the answers, and you can fill them in, but it's basically a sort of summary of some of the things that you should know. So weather is the day-to-day condition of the atmosphere. So the weather's what we have today is different from tomorrow, is different from yesterday, whereas climate is the average weather recorded over the last 30 years. As air cools, it sinks, creating a belt of high pressure. Warm air rises, and as warm air rises, it creates a belt of low pressure. There are 3 interconnected cells of air in each hemisphere, and I'm going to explain that in a minute. And there's a hot, wet climate around the equator as warm air rises. Okay, so just a summary, you might want to jot that down, fill it in on the sheet, whatever you want to do. Okay, so one of the key concepts that we did at GCSE right at the start of year 10, so it's a long time ago, and many of you really struggled with this concept when I taught you it in year 10. So global atmospheric circulation is absolutely vital to the global hydrological cycle, because basically it's the movement of air and moisture in the atmosphere, so it's the movement of water in the atmosphere, which is a major part of the hydrological cycle. So, if you look at the images on the screen, basically you've got a picture of the world chopped in half, and the equator is obviously at 0 degrees, and then the 2 poles at 90 degrees. So you've got 0 degrees is the equator, 30 degrees north and south, 60 degrees north and south, and then 90 degrees in the North Pole and the South Pole. So, at the equator, so 0 degrees latitude, warm air is rising. Okay, we know this, you know this already. So on the equator you get loads of rainforests. That's not by chance, that's because you've got perfect climatic conditions. It's really hot on the equator, so that causes a lot of heat to hit the surface of the ground. That causes any moisture to evaporate, water vapour to rise into the atmosphere, condense, form clouds, and then rain. So on the equator you've got rapid rising air, so really low pressure, lots of clouds, lots of rain. It's also really hot on the equator because it's so close to the sun. Okay, then if you move north or south of the equator, and it's exactly a mirror image, so we're just going to look going north, the air moves high up in the atmosphere towards the north, and you can see in the image that as the air moves, as it cools, it moves towards the north. As it moves further away from the equator, it cools down, and eventually, at about 30 degrees north, the air sinks. Okay, and you can see that on the diagram. Where the air sinks, you get high pressure. So you get really high pressure, you get very little in the way of clouds, very little moisture in the atmosphere, and therefore you get hardly any rain. And that's why if you look at maps and things, on 30 degrees north and south of the equator, you get lots of deserts, because it's high pressure, air's sinking, very little rain. Okay, so the Sahara Desert, 30 degrees north, very little rain. It's also quite hot in these deserts at 30 degrees, because you're still fairly close to the sun. Okay, then what happens from 30 degrees, the warm air from the desert, so Sahara Desert wind, moves north, and you can see the wind from the Sahara can sometimes move across the surface of the sand towards the Mediterranean and up into Europe. And we sometimes get kind of Saharan sand on our car, for example, when it's been a really strong southerly wind towards us. Basically, that warm air moves north quite close to the land surface, picks up any moisture, and then eventually at about 60 degrees north, that air will rise. It's forced to rise above the cold air coming down from the North Pole. Okay, and again, you can see that in the image. So warm Saharan desert air is moving north, cold polar air from the North Pole is moving south. Cold and warm air don't mix. So the warm air is forced to rise, the colder air is denser, so the warm air will rise above it. And as a result, you have rising air at 60 degrees north, and you get kind of really unsettled, rainy, cloudy conditions, a bit like what the weather's like today. Drizzly, not very nice, can be windy because a pressure difference will also cause wind. And generally quite unsettled conditions 60 degrees north, which is roughly, the UK is about 52 degrees north, so we get quite varied weather. And then as you move to the North Pole, and like I said, this is exactly the same in the south, the air sinks the further north it goes, and it sinks at the North Pole, creating really high pressure. So it's really dry in the North and South Pole. The Arctic and the Antarctic get very little in the way of precipitation, but instead of it being a hot desert, the Antarctic is a cold desert. Okay, the Arctic isn't called a desert because the Arctic's an ocean, but the Arctic Ocean is permanently frozen right at the North Pole, and that's because it's so far away from the equator. You've got high pressure and very little heat. Okay, so that's global atmospheric circulation. So warm air rises at the equator, that drives the whole cycle. So as that warm air rises, it moves north or south, it then sinks 30 degrees north or south, it then travels north or south and then rises at 60 degrees before sinking again at the North and South Pole. And there are three cells basically. So the Hadley cell is the one at the equator, the Ferrel cell is the one that's between 30 and 60 degrees north, and then the polar cell is the one that's between 60 degrees and 90 degrees north or south. Hopefully that explains it and recaps it a little bit for you, but there are some other resources you can search up if you're still unsure. So BBC Bitesize GCSE has got a really good link to this. So your task 2 is in your notes to kind of make some notes about global atmospheric circulation. So you might want to print some of the images, you might want to do a bit more research on it, but basically make sure you understand. And in order to make sure you actually understand it, a good idea is to answer the questions on the slide. So rather than just writing out what everything means, how do you apply that understanding? So why are there deserts at 30 degrees north of the equator? What is the climate like at the equator and why? What areas experience high or low pressure and why? And why is the climate in the UK so variable? So write some notes, have a go at the questions, make sure you understand, because it will really help you with the rest of the A-level. Okay, the next part of the learning objective is looking at factors that affect temperature. So if we think about global circulation, we would think like everywhere around the equator is going to be really hot and rainy, everywhere 30 degrees north and south is going to be really hot and dry, and so on. But obviously the world isn't that simple. There are other factors that affect the temperature. So the map on the screen shows the annual mean temperature across the world. So obviously the red areas, the dark red burgundy areas are the hottest areas, and then the white pinky areas are the coldest. So as you can see, the Arctic is not quite as cold as the Antarctic. So the Antarctic is far, far colder, and we'll come back to that in a minute. Even though it's quite clear that the area around the equator is hotter than most of the world, there are some anomalies on the map. So for example, the west coast of South America, so running down sort of Peru, Chile, down to Argentina, you've got much cooler temperatures than the rest of that latitude. And so there are lots of different factors. But generally, the pattern is the closer to the equator you are, the hotter the temperature. The further away from the equator you are, the cooler the temperature. And that factor is called latitude. So latitude is the distance from the equator. Okay, so looking at some anomalies then on this map, there are many other factors. So one factor, if you look at the map on the screen, the pink arrow shows the Himalayas. Okay, so Himalayas are about 30 degrees north of the equator. So you would expect the temperature to be fairly hot because you're not that far away from the equator. The air's sinking, so it should be quite sunny. However, mountains have much lower temperatures. So for every 100 metres you climb, the temperature falls by 1 degree Celsius. So the Himalaya mountains are far, far cooler than other places at a similar latitude, and that's simply because they're higher up. Other examples where altitude has affected the temperature are the Andes Mountains on the west coast of South America that I just explained in the previous slide. Even in Africa, in East Africa, you can see two little yellow spots. So that's the Ethiopian highlands and Mount Kenya and Mount Kilimanjaro in Tanzania, because they're really high mountains. And even though they're on the equator, so Mount Kilimanjaro is on the equator, obviously they're really high up, so the temperature is much cooler. So altitude is also another impact on temperature. It also impacts the amount of rain as well and the amount of precipitation. Another factor is land and sea, and a really good example where you can see this is the fact that Antarctica is far, far colder than the Arctic. So the Arctic is kind of dark blue with bits of Greenland that are purple, whereas the Antarctic is almost all white and purple, so far cooler, down to sort of -50. And that's to do with the difference between water and land and how quickly water and land heats up and cools down. So water takes much longer to heat up and cool down than land. And so as a result, in Britain, if you live on the coast, you're much more likely to have cooler summers and warmer winters. So in Sidmouth, for example, our summer temperatures will probably be a couple of degrees cooler than Honiton because we're near the sea. And likewise, in the winter, we're much less likely to get snow or kind of freezing temperatures than Honiton because we're near the sea. In the summer, the sea keeps us cool, and in the winter, the sea keeps us warm because the sea takes much longer to cool down or heat up. Okay, and again, that's why Antarctica is much cooler, because it's a land mass, whereas the Arctic is actually an ocean, and so it takes longer to cool down and heat up in the summer and winter. Another thing linking to oceans is ocean currents. So there's something called the thermohaline circulation, which I'll explain next lesson. But basically, the entire world's oceans are linked by currents. I will explain this next lesson, but it all kind of starts off in the Arctic, where you've got melting ice in the summer. So in the summer, the ice melts every year, and that causes something called chimneys, which is massive kind of waterfalls of cold water, because cold water is dense and it sinks, and then that pulls up warm water from further south to take its place, and it drives this conveyor belt of ocean currents around the world. And this is why in the UK we have a much warmer temperature, or a much milder temperature, than places of similar latitude. So if you look at the world map, you'll see that inland Canada, Moscow in Russia have much cooler winters and much warmer summers than we do. They have much bigger extremes in temperature, bigger range, and that's because we have the Gulf Stream, the North Atlantic Drift, the red arrows on the map, driving water from the Caribbean towards our coastline. So it makes our climate generally much warmer than it should be for the latitude. And the UK is quite unique. In contrast to that, there's a really cold current off the coast of Peru and Chile, which make the waters there really chilly and also add to the fact that the west coast of South America is really cold. Okay, another factor is if you look at this map, basically the equator obviously goes right the way through the middle of Brazil, the Congo, very close to North Australia, Indonesia and so on. But actually the hottest temperatures are often experienced slightly further north, 30 degrees. So the Burgundy areas in northern Africa, the Sahara Desert, parts of Iran, the Lut Desert in Iran, are not found on the equator. And that's because the high pressure means there's less cloud. And that means that sunshine can heat the earth much more effectively. So if you've got cloud, then it stops some of the heat getting to the surface of the earth. And that's why actually, although the Sahara Desert is further away from the equator than the Amazon rainforest, the average temperature is actually higher because there's no cloud there, so the heat heats it up. In contrast, nighttime temperatures in the desert can drop significantly, even sometimes below freezing, because where there's no clouds, any heat escapes really quickly. So quite interesting, cloud cover can really affect temperature as well. The last factor is the albedo effect. This can link to clouds as well. Basically, the whiter the surface, the higher the albedo, and the more of the sun's energy is reflected back to space. So darker surface areas such as the rainforest or the oceans have a much lower albedo, so they absorb much more of the sun's energy. So in the diagram you can kind of see how the difference between green areas where 70% of the sun's energy is absorbed, whereas in the Arctic or the Antarctic 85 to 90% of the sun's energy is reflected straight back to the atmosphere, therefore making a huge difference, and it has a massive impact on temperatures. So mountain tops will have a high albedo, the poles will have a high albedo, but also areas that have really high cloud cover, that cloud will reflect some of the energy back. And you can kind of think about that if you're on the beach and it's a really sunny day and then the clouds come over, you instantly feel a bit cooler, and that's because the cloud is reflecting some of that heat energy back. Okay, so task 3 is to complete notes on all of these factors. So I have put a sheet and show my homework if you want to just fill that in with basic explanations and some examples, just to remind you of what these different concepts mean. And then lastly, you need to know that there's different types of rainfall as well, so different reasons why rain falls in some areas and not others. The first one is convectional rainfall. So convectional rainfall is the type of rainfall that is created purely by the heating from the sun. So the equator has the most convectional rainfall because on the equator the sun's energy is really intense, it heats up any moisture on the ground, it causes rapid evaporation, which causes clouds, and it rains, and that's convectional rainfall. In this country, we sometimes get convectional rainfall when we've had a really hot, sunny period, and then we get big thunderstorms that have built up because of that. Another type of rainfall is relief rainfall. So this is where it rains more on the top of hills than it does anywhere else, and that's part of the reason it rains more in Dartmoor than it does, say, in Exeter. So rainfall totals in Dartmoor will be a third more than the rainfall totals in Exeter, and that's because as the air is moving onshore, as it reaches higher ground, the air is forced to rise, and any air that's forced to rise will condense, form clouds, and then it rains on top of the mountains. When that cloud has lost all the moisture, the other side of the mountain or hill will get less rain, and we consider that as being in the rain shadow. So some examples, obviously Dartmoor, and then Exeter is in the rain shadow of Dartmoor, so it experiences far less rain than Dartmoor does. In the Himalayas, the Gobi Desert is behind the Himalaya Mountains, so the Himalaya Mountains receive a lot of precipitation, and the desert behind is partly due to the fact it's in a rain shadow. And finally, frontal rainfall, which is more tricky to understand in one way, but it's simply where cold air and warm air meet. And where you have cold and warm air meeting, they don't mix. So the warm air is always forced to rise above the cold air. And where, again, because the warm air is rising, you get clouds, you get rain. And we get a huge amount of frontal rainfall in the UK because we are right on the boundary between polar air coming from the north and then the warm desert air coming from the south. And we're kind of right by where those air masses meet, and that causes fronts, which cause rain. Okay, and then the last task is to complete the sheet about the types of rainfall so that you have all of this information in your books as a good recap of what you did at GCSE. I will see you on Tuesday for a Google Meet, but you've got the rest of this lesson and you might need to do some for homework to complete all of the tasks. I hope that helped. Bye.